Hello, my dear students. How are you all? I am fine. I am Khondokar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttora. During this pandemic situation, welcome you all to our online chemistry class. My dear students, today we discuss about some important creative question from chemistry first paper, chapter 4, chemical change. My dear students, here in this term given container A 160 ml 0.1 molar ammonium hydroxide solution, in container B 60 ml 0.1 molar hydrochloric acid solution, that means HCl solution, and in container C the mixture of A and B solution. My dear students, to solve this stem we have to know this formula. At first, what is pH? pH is the negative logarithm of molar concentration of hydrogen ion. pOH, that is minus log of molar concentration of hydroxyl ion, and then pH plus pOH, that is 14, and this is at 25 degree Celsius temperature. And after that, alpha, this alpha is degree of dissociation of acid, because we use here Ka, alpha equal to root over Ka by C, and alpha equal to root over Kb by C. This is for acid, weak acid, and this is for weak base. And for weak acid, molar concentration of hydrogen ion equal to alpha C, and for weak base, molar concentration of hydroxyl ion equal to alpha C. And for acidic buffer solution, my dear students, for acidic buffer solution we use pH equal to pKa plus log of salt, molar concentration of salt divided by molar concentration of acid. And for basic buffer solution, my dear students, pH equal to 14 minus pKb minus log of molar concentration of salt divided by molar concentration of base. Now, my dear students, we solve the creative question. Our first question is calculate pH of the solution of container A. And my dear students, here we see that in container A ammonium hydroxide solution is present, and here 160 ml 0.1 molar ammonium hydroxide is present. Kb value of this ammonium hydroxide is 1.8 into 10 to the power minus 5. My dear students, we know that ammonium hydroxide is a weak base. So to calculate the pH of this ammonium hydroxide, at first we have to calculate degree of dissociation of this weak base. So my dear students, we use Ostwald dilution law, and according to Ostwald dilution law, we know that we get alpha equal to root over Kb by C. My dear students, here the Kb value is Kb equal to 1.8 into 10 to the power minus 5, and the given concentration of a weak base, that is C, equal to 0.1 molar. My dear students, so alpha equal to root over 1.8 into 10 to the power minus 5 divided by 0.1, and we get the value alpha equal to 0.0134. and for weak base, molar concentration of hydroxyl ion, again for weak base, molar concentration of hydroxyl ion, that is alpha C. So alpha equal to 0.0134 into the given concentration, that is 0.1, and we get the value 1.34 into 10 to the power minus 3. So molar concentration of hydroxyl ion of this ammonium hydroxide, that is 1.34 into 10 to the power minus 3 molar. Now my dear students, for base we get POH equal to minus log of again POH equal to minus log of molar concentration of hydroxyl ion, that is minus log of 1.34 into 10 to the power minus 3, and we get the value is 2.87, my dear students. So the POH value of this ammonium hydroxide solution is 2.87, but we have to calculate the pH of this solution. So we use pH plus POH equal to 14, this formula. No, pH plus POH equal to 14, so pH equal to 14 minus POH, that is 14 minus 2.87, and we get the value is 11.13. So my dear students, we can say that the pH value of ammonium hydroxide solution is 11.13. Now my dear students, our next question, calculate pH of the solution of container B. My dear students, we can see that in container hydrochloric acid is present, and we know that hydrochloric acid is a strong acid. So my dear students, in solution in HCl solution, the dissociation rate is 100%, and for that reason the concentration of hydrogen ion, that is 0.1 molar, my dear students. And we know that what is pH for strong acid, pH equal to minus log of molar concentration of hydrogen ion. So my dear students, here we use the molar concentration of hydrogen ion equal to 0.1 and minus log of 0.1, that is 1. So my dear students, we can say that the pH value of container B solution, that is HCl, is 1. Now my dear students, our next question is calculate pH of the solution of container C. My dear students, we can see that in container C, this is the mixture of A and B solution. So my dear students, we can see that the reaction of ammonium hydroxide NH4OH plus HCl reacts and they produce ammonium chloride plus water. So my dear students, at initial state ammonium hydroxide present 160 ml, concentration is 0.1 molar, and HCl present 60 ml, concentration 0.1 molar, and ammonium chloride is 0 ml. This is at initial state, but at equilibrium, that means in mixture 60 ml hydrochloric acid reacts with this ammonium hydroxide, and we get 160 minus 60, that means 100 ml ammonium hydroxide, and amount of HCl is now 0 in mixture, and ammonium chloride present 60 ml, and concentration is 0.1 molar. So my dear students, we can see that in mixture here present 100 ml ammonium hydroxide and 60 ml 0.1 molar ammonium chloride, which is the salt of this ammonium hydroxide, and that's why this mixture forms a basic buffer solution. This is basic buffer solution. So my dear students, we know that the pH formula for basic buffer solution is pH equal to 14 minus pKb minus log of molar concentration of salt divided by molar concentration of base. This is the pH equation of basic buffer solution, my dear students. So my dear students, at first we calculate molar concentration of salt. We use dilution law. That means if the concentration of molar concentration of salt is S2, then this is V1 S1 divided by V2. V1 S1 is the initial volume and concentration of salt. This is 60 into 0.1, concentration 0.1 divided by total volume. My dear students, total volume is 160 plus 60 ml, and we get the value is 0.027 molar. And for base, my dear students, for molar concentration of base, H2 prime, which is equal to V1 prime S1 prime divided by V2. That is V1 S1 prime is the initial volume and concentration of this base, and we use the value of V1, that is 100 ml into 0.1 divided by 160 plus 60, and my dear students, we get the value is 0.045 molar. Now we calculate the pKb value. Now my dear students, what is pKb? pKb equal to minus log of kb, and we get minus log of 1.8 into 10 to the power minus 5, and the value is 4.745. So my dear students, now we calculate the pH of the mixture, and we get the formula pH equal to, this is 14, and pKb value is 4.745 minus 4.745 minus concentration minus log of concentration of salt, that is 0.027 divided by concentration of molar concentration of base, that is 0.045, my dear students, and we get the value pH equal to 9.47. So my dear students, we can see that the pH value of container C solution, that is 9.47. My dear students, our next question: if a small amount of acid or base added to the solution of container C, then will there be any change of pH of the solution. Analyze, my dear students. We can see that this solution, that means the mixture of A and B, is a basic buffer solution. So, my dear students, ammonium hydroxide in mixture, ammonium hydroxide dissociate and they produce ammonium ion and hydroxyl ion, and this ammonium chloride salt, ammonium chloride, this produce ammonium ion plus chloride ion. My dear students, when we add small amount of base in this mixture, then we get hydroxyl ion from this base, and this hydroxyl ion reacts with ammonium ion which comes from this ammonium chloride, and they produce ammonium hydroxide. My dear students, ammonium ion reacts with hydroxyl ion and they produce ammonium hydroxide, and due to the common ion effect, this ammonium hydroxide cannot be dissociated, and that's why the molar concentration of this hydroxyl ion remain unchanged, and that's why the pH remain unchanged, my dear students. And if we add small amount of acid in this buffer solution, basic buffer solution, and we get hydrogen ion from this acid, and this hydrogen ion reacts with the hydroxyl ion present in the mixture and they form water, my dear students. Due to formation of water, the concentration of hydroxyl ion decreases, but this ammonium hydroxide is weak base. According to Le Chatelier principle, this ammonium hydroxide now dissociated and the concentration of hydroxyl ion remain unchanged, and that's why the pH of this solution remain unchanged, my dear students. Here the reaction occurs, H plus plus OH minus produce H2O. So we can see that if we add a small amount of acid or base in this basic buffer solution, then the pH of this buffer solution remain unchanged.